Well, hello everyone, and welcome to the August 2023 edition of the St. Louis Java Users Group. For those who don't know, the St. Louis Java Users Group is an informal group. Attendance is free. There is no formal membership list. Our normal meeting date is the second Thursday of every month except December, when there is no meeting. There's just too many things going on over the holidays for us to be able to organize a meeting in December. You can join us for food when we meet in person. You can join us for food and social at 6 p.m. and the presentation and meeting will actually start at 6:30 p.m. When we meet in person, our normal meeting location is in the Object Computing Incorporated training room, and that's at 12,140 Woodcrest Executive Drive, Suite 310, and that is, of course, in St. Louis, Missouri. I'd like to introduce the other members of the St. Louis Java Users Group Steering Committee. So from left to right, we have Ted Doyle, Todd Zimmerman, Bruce Allspaw, that's me in the middle, Wei-Chi Gao, and Kathy Zwang. You can reach all of us on the steering committee by sending an email to that address listed there at the bottom of your screen. That's javasigsc@ociweb.com. So the way to remember that is it's Java, SIG is Special Interest Group, and SC is Steering Committee at ociweb.com, because I'll get to in a moment, OCI is our original founding sponsor. And I'd also like to welcome our latest steering committee member, Robert Levitt. So the St. Louis Java Users Group would not be possible without the support of our sponsors. So I've got their logos here up on the screen. So from left to right, we have Object Computing Incorporated. They are our original founding sponsor going back to 1997, when the jug was originally created. And yes, we really have been meeting every month except December, going back to 1997. And they have sponsored, they filled in for all kinds of things over the years. So thank you to Object Computing Incorporated. And like, for example, thank you for letting us use your training room when we meet in person. JFrog is also an important sponsor. They sponsor the fees for the Zoom subscription, which makes this remote meeting possible. So thank you to JFrog for sponsoring the Zoom subscription. Signature Consultants and Adaptive Solutions Group are both headhunters. And when we meet in person, they will typically sponsor the pizza. We haven't figured out a way how to deliver pizza, over Zoom, but when we meet in person, that's what they do. But if you're looking for a Java position, or if you have a Java position that you would like to fill, just do a quick Google search on either one of them and let them know that you found out about them through the St. Louis Java Users Group. JetBrains has been sponsoring for us 2 JetBrains desktop products of your choice at each of our monthly meetings. So at the end of this meeting, we will have a raffle for 2 JetBrains licenses for any other, whether it's IntelliJ or any of the other products. However, you must be present to win. Sorry, if you're watching the recording, you're too late. You do have to be present to win to participate in the raffle at the end of the meeting for the JetBrains licenses. Elastic has also been a sponsor, and they're the company behind Elasticsearch. They have sponsored gift cards. Intertech is a training company. They sponsored the famous Screaming Flying Monkeys. What? Screaming Flying Monkeys? Well, they're just little dolls, and if you throw them up against the wall, they scream. They've got kind of a little rubber band thing, and they're a lot of fun. But they also sponsor coffee cups and mouse pads and things like that. They are a training company. So if you go to the Intertech website, you should be able to find lots of useful training videos on Java and other languages as well. They're a good company and they have lots of good videos for training. At the end of this meeting, we will also be raffling 2 Manning ebooks of your choice. And again, you'll have to be present to win. So if you're watching the recording, I'm sorry, you do have to be present at the end of the meeting to participate in that raffle. And Pearson will also sponsor physical books as well when we meet in person. So thank you to all of our sponsors for helping us out. We really appreciate it. As far as announcements go, the Strange Loop Conference in St. Louis is coming up. That will be September 21st through the 22nd at St. Louis Union Station. And I'm told this may be the last Strange Loop Conference that'll be taking place. I'm not sure. But if you want the details on how to sign up and go to that conference, it's there on your screen. The website is The Strange Loop, all one word, .com. So as far as upcoming presentations go, on September 14th, we've got GraphQL from the ground up by Jason Clark. And so you can go ahead and RSVP for that meeting now. It's up on the website already. And so in order to keep up with the upcoming presentations, the way to do that is what you've probably already done. You went to meetup.com/gatewayjug. And as soon as meetings are scheduled, we put them on the meetup site, and you can go ahead and RSVP for that. Now, if you are interested in giving a presentation, or if you would like to sponsor the Jug, you can email the steering committee at that same address that I gave you before. That's javasigsc@ociweb.com. And we're always open for good presentations. So that brings us to tonight's presentation. You're probably tired of listening to me talk. We'll actually have 2 presentations here back here tonight, and they both involve Kotlin or Kotlin, and I'm sure John will correct me as far as the correct way to pronounce this. We'll have an introductory presentation to the language, followed by another presentation that will talk about the functional features of the language. And John Burns works at Grubhub, and he is also involved in the user group for whether it's Kotlin or Kotlin. I'll let him decide how he wants to pronounce it. So those are my announcements. What I'm going to do is I'm going to stop sharing at this point, and that will allow John to take over the screen, and I'll let you take it away here, John.
Okay, thank you. Let me make sure I have everything set up here. Okay, how does that look?
Yeah, I can see you just fine.
Okay, my screen is sharing good?
Yes, your screen is
okay.
sharing, and I can hear you just fine.
Okay, perfect. Awesome. Well, thank you so much, Bruce. And like you said, I'm John Burns, and I just want to thank you for having me here and the rest of the steering committee for inviting me to talk for your group. I am from Chicago, so we're practically neighbors. And I'm actually here in St. Louis right now because actually at first I didn't realize you were still fully online, and figured it'd be a good chance to take the family down to St. Louis for a weekend. So we're all down here enjoying this beautiful city. And so I'm really feeling St. Louis, even though we are still meeting remotely. So yeah, I have 2 presentations here. It is Kotlin, generally how it's pronounced. And the first one is basically it's brand new one. I've never given this talk before, but I wanted to put together something that is going to introduce Kotlin to people who maybe have not used it at all yet. I'm really thinking about a lot of the developers that I know who have been doing Java for years, maybe many years, and have heard about this Kotlin thing, but haven't had time to look into it yet, and are kind of wondering what it's all about. Do I need to think about this thing? What do I need to do about it? And so I just want to give a very gentle introduction of Kotlin, what it is, and how it like what its most important things to you as a Java developer probably are. And then my second presentation is going to be about Kotlin as a functional language in terms of functional programming, which is pretty trendy these days. but Kotlin does have some specific features that help with functional programming, and that is the talk I gave at DevNexus this year, where I was lucky enough to meet Bruce, and we had a good time. So I will give that presentation second. In between, we can do a short break. I'll answer some questions about the first presentation, just very quick break. But if someone needs to go grab a drink or something like that, go ahead and do that there, and then I'll go into the next one. So I don't want to take too much time here. So let's get started. So again, yeah, my name is John. I'm a staff engineer at Grubhub, where I work on the service platform team. I'm also the organizer of the Chicago Kotlin user group, and I help out with the Chicago Java user group as well. I'm also the maintainer of KT-Link Gradle, which is the most popular Gradle plugin for linting Kotlin code. And you can find me on social media, or you can find me on GitHub and Fediverse, Mastodon. There, I'm not really on Twitter anymore. So yeah, I work at Grubhub. So just a quick plug, because they put my bill to travel around and do stuff like that, speak at places. But if you're interested in Grubhub, we do have some remote positions and whatever. You can talk to me. But we're based in Chicago. We're a homegrown Chicago company. So representing the Midwest tech scene here. So real quick, let's talk about the history of Kotlin. So some of you might know, but might not, that that Kotlin was released in 2011. It actually is not as new as some people might think. So it gained popularity more recently, though, in 2017 at Google I/O. Google announced that it was going to be the way forward for Android development. And that's what really brought Kotlin into the mainstream. Up until then, it had kind of been like this beta language. No one really knew if anyone was going to use it, but that's really what kicked it off. In terms of backend development, server side, it's gradually been gaining popularity. So in 2016, Pivotal, now VMware, added Kotlin as a language option to start.spring.io when you generate a new Spring Boot project. In 2018, the Gradle Kotlin DSL was launched. So that allows you to write your Gradle builds in a Kotlin scripting language rather than the traditional Groovy scripting language. In 2018, Spring Boot 2.0 was released, which actually some of the implementation code in Spring Boot 2 is written in Kotlin. So Kotlin is actually integrated into Spring framework itself now. And if you're running Spring Boot, you already have the Kotlin standard library on your class path. And in 2023, that's this year, Gradle announced that the Kotlin DSL is now the official main language to write build scripts in for Gradle. So that kind of brings us to where we're at today. So what is Kotlin? What makes it different? The basics are that Kotlin is a JVM language, right? It's just like Groovy or Scala. It's another language that compiles to Java bytecode, right? It does some other things too, but that's not important right now because we're talking about how it pertains to Java development. So some of the features that sets it apart from Java are that it's multi-paradigm, and I'll talk a little bit more about this in detail in my other talk. Java technically is also multi-paradigm, but what I mean by multi-paradigm is that it supports both object-oriented and functional programming paradigms, or styles of development, to not use such a fancy word. You can do both in Kotlin, more so than Java. It has a modern design inspired by Swift, Cylon, and Scala. So Swift is very popular in the iOS space. Scala, really brought functional programming, non-Lisp functional programming to the JVM. And Cylon, you might not have heard of, but that was a language that was under development in the late 2000s, early 2010s, and it didn't really go anywhere. But Kotlin borrowed a lot of its ideas from Cylon. And it has a practical design philosophy. And I think this is a very important point. When you look at a language like Scala, oftentimes it feels very academic. Basically, you kind of can imagine the creators of it thinking, well, any true functional programming language is going to have this concept in it. So we better put it in the language. It has to be there in order for us to academically call this language a functional programming language or what have you. That is not how Kotlin is developed. Kotlin is developed by JetBrains, right? So they're trying to build tools for the practical developer trying to get their job done. So that means the only language features they put in are ones that are going to be a big bang for the buck, give you a lot of productivity gains or safety gains without adding too much cognitive load to the developer. That's really how they weigh it. So they kind of start from a baseline of Java and say, anything we do that's different from Java, we want a really compelling reason why. And it has to be worth the price that we're going to pay, where people have to learn this thing now. So why should you use Kotlin? If you're already doing Java development, what is the reason to actually use Kotlin instead of Java? For one, it's basically just like a more modern version of Java. Now, Java is a great language and it has a great implementation. And the JVM is really, I mean, the true power behind Java is the JVM, right? But Java is also committed to being backwards compatible. And so a lot of its APIs are starting to show its age, right? And they're starting to clean up some stuff and modernize it a bit in some of the recent Java versions, right? There's some really nice features coming out in Java that have come out in Java 17, coming out in Java 21. But we're not always using those latest versions of Java, right? Sometimes we're stuck even maybe on Java 8. And we can't have access to those. And that's outside of our control, right? We have our infrastructure and that's not under our control. Well, using Kotlin on Java 8, you can access some of these more modern language features without having to upgrade your JDK. So like I said, the API is a fresh start. We don't have to worry about some of those old clunky APIs that exist in Java, because they were able to just say, you know what, we've learned from the how many of decades of Java usage, and we can learn from some of the mistakes that were made early in Java development. And the other one, the one that this talk is going to really focus on, is this book, Effective Java. So this book right here, if you haven't read this book, I highly recommend getting this book, Effective Java by Josh Block. It really shows you how you should write Java, because Java will let you do many things, and you'll find examples online that say to do many different things, and some of them you shouldn't do. We've learned a lot about Java over the decades, and a lot of those very, very basic best practices are built into this book here. And it's a really great guide for programming Java. But the nice thing that Kotlin does is Kotlin takes a lot of the information that's in this book and just bakes it into the language, makes it the default. And so you don't have to think about it as much. You don't have to remember what's in this big book. I guess I didn't show you the side of the book, but it has some heft. If you rewrite this book for Kotlin, it's less than half the size, because so much of the stuff is just happens automatically now. So I'm going to go through individual items from Effective Java and show you exactly what I mean by this. But first, I want to just take a couple notes on syntax for Kotlin, because I don't want my examples to be confusing to you when you see them. There's a couple things you should know about the syntax of Kotlin that you might not, and I don't want them to cause confusion later. So first of all, types go at the end of a declaration. So whereas in Java, you will have a declaration like this. You say the type, the name, and then you assign it a value. In Kotlin, it looks like this. So we start with a keyword, val or var, depending on if it's final or not final. Then we have the name, then a colon, then the type. And that's the same for functions. The colon comes after the declaration and then the type. And then we can do our assignment or declaration. The other thing to note is that we can lift lambdas parameters out of the enclosing parentheses. So take a second to digest this code. But right here, we have a Java function called mutate string. And it has two parameters, right? One is a string, the other one is a function, right? That's a functional interface in Java. That means we can express any parameter we're passing in as a lambda, right? So you see on the bottom here, when we call mutate string, we can give it a string and then we give it a lambda, right? There was a function of string, so it's a lambda that takes a string and returns a string. And that's how we express that parameter, right? It's just a parameter. In Kotlin, we can invoke that exact same function in a different way. Basically, it looks very similar. You'll notice that in Kotlin, the incoming parameter to the lambda is actually inside the curly brace instead of outside the curly brace. That's one difference. But the other difference is that final parentheses that closes out the mutate string call is actually before we open up the lambda. And that's just a syntactic sugar that Kotlin has. If the final parameter is a lambda, you can do that trick. And the reason why they did that might not be clear. It probably won't be clear, and that's okay. I just want you to know about it for now so that you can understand the code examples I'm showing you. And we'll talk a little bit more about why that language feature is there a little bit later. Okay, so let's move on to some of the items in effective Java. So item number 2 of effective Java says, consider a builder when faced with many constructor parameters. Okay, so what does that mean? That they're talking about the builder pattern. That's when we have a object that takes many parameters, usually like a data object, right, with many fields. We'll end up with like a constructor like this. Now, this example here is not that many; it's only 3, but I'm trying to fit it on the slide. But you can imagine that this can grow, right? You can eventually have many fields, and the constructor gets long. And anytime you make a change, then it breaks all the calls to the constructor, right? And you have to refactor it all, and that gets messy. So you should do a builder pattern, right? This is all still Java. This is my attempt to slam all the boilerplate of a builder onto a single slide, right? So some of this is very condensed, but the idea is that you have this kind of static inner class where the builder helps you create the object. You can have like the fields on the builder. And again, this static class is in addition to the other stuff we already saw, right? But we can call methods to set values on there and then call build at the end. And if you want like a default value, we'd have to like bake that into the build method to say, well, if this is null, then let's replace it with the default value. If you have required values, then you still have to put it in the constructor of the builder or something like that. But basically, this is a lot of boilerplate, right? And for all of this effort, what we can do is do this. Now we can say, oh, let's create a new chat message builder, pass in the required parameter, then let's set an optional field of message, and then let's build it. All right. In Kotlin, we have data classes, and data classes give us flexible constructors. And really, actually, all classes give us flexible constructors in Kotlin. So I'll talk more specifically what data class gives us later, but for now, I want to focus on how it replaces the builder pattern. So when we have this object called chat message that has 3 parameters on it, we have the ID, the timestamp of the message, same as the Java one. But if we want to create one, and we only want to set message because we want the timestamp to just get the default, which is declared there. You can do default parameters in Kotlin, yeah. So if we wanted to do that, we could do it by just specifying the parameters we want to set. So you notice the parameter has a name there, message equals. That's a named parameter. So it's still just a call to the chat message constructor. But because the chat message constructor is actually, there's many constructors under the hood in the JVM and the bytecode. We have to tell it we're calling the one that takes a single parameter of type of name message. But there's another constructor that takes one parameter with the parameters called timestamp under the hood. We don't see it. It just all happens under the hood. So to tell Kotlin which one we're actually trying to call, other than type, we also have to give it the name if there's multiple that have the same type. So my point is, this requires no builder boilerplate, right? We don't need Lombok to generate us a builder. We don't need to write all that static builder class. We just get it for free. Moving on. All right, item 3, enforce the singleton property with a private constructor or an enum type. So this is talking about the singleton pattern, right? If we want a class where there's only ever one instance of that class, here's a way to do it, the private constructor, right? So you make it so you can't instantiate it directly. The only way to instantiate it is by calling a static method like get or new instance or something like that. And it will check if the static reference is null, and if it is, then we'll create one. We can call the constructor because it's private and we're in that class, and then we assign it, and then we can return it. This is not the best way to do it. There's some problems with this. So if you're really clever, you'll follow the second thing that item 3 mentioned, which is an enum class. This is another way to do a singleton. Now, semantically, this is a little confusing, right? Because it's not actually an enum, really. What you're talking about here is a singleton. So it's just a trick of using how enums work in Java and how they are actually classes to make a singleton. So it's clever, and it's not much code, but it's still it's not semantically clear what you're trying to do here. So in Kotlin, we have something called an object. And an object is like a class declaration, except for it is just naturally a singleton. You can only reference it statically, and there will only ever be one. So you don't have to worry about implementing singleton on your own. Moving on. Item 4 says enforce non-instantiability with a private constructor. Okay, so that a lot of these sound very heady, have a lot of big words, but what they're talking about here is utility classes. So utility class is usually a class that only has static methods, and they contain what we call pure functions, right? Functions that take an input, return an output, deal with no state. And so when we have those in Java, generally we create like a util class, and then we put a bunch of static methods in there. Like these are all of our static methods. We'll just like throw them all on there. And you should never instantiate that class because all the methods are static, right? So give it a private constructor so you don't accidentally construct it. So in Kotlin, we have top level functions. So we could just declare a function, like not even inside a class, just in a something.kt file, you can just declare a function. Done. Don't need to worry about a class at all. Just eliminate that boilerplate, and you can just call that function from anywhere. It's just basically like statically imported. Moving on, and again, I'll take questions in between the two presentations. So if you have questions on this stuff, you won't have to remember them for too long. So the next, like items 10 through 13 and number 16, I wanted to kind of lump all together. These are all items. You can reference them in the book, but they're all things that talk about methods common to all objects. All right. So if you have something like a data class, right, this is not going to cut it, right? A class with a string field called data, not going to cut it in Java, right? Because first of all, you need getters and setters, right? You need that encapsulation in case you ever need to change the way it's accessed or set. So you got to have that encapsulation, right? And then if you're doing that, you also have to make sure that you implement equals properly. You have your hash code there implemented, so you, in case you ever use it in a set or a map key. And if you want to ever copy it, well, you got to make sure you implement clone properly. And I don't even want to get started on that, right? So this is a ton of boilerplate. And yeah, there's tools like Lombok that can generate a lot of this for you, which I wholeheartedly endorse if you're using Java. Well, there's some gotchas, maybe not wholeheartedly, half-heartedly endorse. Right? But if you're in Kotlin, you get a lot of that for free, because in Kotlin, we have something called data class. So when you declare a data class that has fields on it, for example, this one called data of type string, then we can create it just the same as we create any other class, like through a constructor. But if we print it, if we access it, like instance.data, it's actually using the getter under the hood. So this is called property syntax. In Kotlin, it looks like you're just accessing the property directly, but under the hood, it is actually calling the getter, following the Java bean specification. This is useful because it just like makes code a little bit clearer, and it just basically because they can, because the Kotlin has the ability to, like, you can override the getter if you want to. So it's just a syntax, that part's a syntactic sugar, but the fact that the setter and the getter is generated. So if you were to call this code from Java, it would have the getter and the setter. That's what you're getting out of this for free. And then also we have the copy method. So if you have an instance of the data class and you can call .copy and pass in any of the parameters, it's not just a straight copy either. You can pass in any of the parameters you would like to change on the copy, and you will get returned a copy of your object, but with those parameters changed to those values that you specified. So that's actually kind of more like the Lombok, like to builder. Like if you do a builder on a class and then you say, also give me the to builder, then you can take an instance and say to builder, and then you get a copy of, you get an instance of the builder based on that instance, and then you can build it again. It's a lot of boilerplate. Copy just gives us that for free. Next, minimize mutability. Well, yes, this is a great idea, right? The more mutable state you have, the more race conditions you might have, the more bugs you might have. So you want to minimize mutability. If something can be final, you should make it final. Right? So in Java, you should always put final in front of your variables unless you're explicitly creating like a property that you want to constantly mutate on. And then I will address questions at the end. I did see a question pop up. I'll get them at the end of this presentation. Also, your classes and things like that should be final, if they can be. If there's no reason or you need them to be not final, then they should always be final. But the problem with that is, right, you have to remember to put final. And your IntelliJ or IDE, you use will remind you to do it sometimes. Or, hey, this could be final. Do you want to make it final? But still, you have to click on that little light bulb and click that thing, or you have to remember to put final in front of everything or almost everything if you're being a good citizen about mutability. Well, in Kotlin, things are a little different. When we declare a variable, we actually have to put val or var. So what that's doing is it's forcing us to think about the mutability right up front. You have to put val or var. And it's easy. You put val or var, you just put one, right? But it forces you for a split second to think about, is this mutable or not? And then it just makes it easier to make that decision of, okay, this is not mutable. I'll just make it val. Val should be your go-to. But because it forces you to write something, you can't forget to do it. And this kind of ties in a little bit with design for extensibility or prohibit. So this is where you talk about classes, like any class that should be final anything that can be final should be final, right? Make your classes final unless you're specifically designing around extensibility. What the book talks about is like all the things you should do to make sure that if your class is going to be not final, how people who are extending your class can have the best experience, or the things you need to do in your class to make that good. And it's a lot. There's a lot in there, and you can read the book. Hopefully Josh Block's sales go up after this talk, but most of the time you don't want to have to worry about that. You're writing this class and you don't intend for anybody else to extend it, right? Put final on it. But again, in Java, you have to remember to put final on it. In Kotlin, the default is final. So in this one, it's even more opinionated than the val-var thing. Default is can't be extended. If you want it to be not final, then you need the special keyword of open to make it open. Moving on. Item 49, we're jumping through the items. We're not going through every single item, but I'm just picking out some of the big ones. Check parameters for validity. So this is just all about doing input validation to your functions. And the one that the book doesn't spend a lot of time on, but I think is actually more important than the others, is nullability. So if you look at this snippet of Java code, how many null pointer exceptions could potentially happen in this code? It's not a hard question. Let's see if anyone answers. I'll give you a couple of seconds. 3. There's 3 different places where you could get a null pointer exception here. And so what you're supposed to do in Java is check for null anytime something could be a null pointer exception. So we've got 3 here. All the times that we're referencing something dot length, that could be a null pointer exception. Right. So the proper thing to do in Java, what the book goes through, is you have to do something like this, where okay, yeah, if this is null, then do this other logic, right? We have to null guard everywhere because everything is nullable by default in Java, right? So you have to check it. It's a lot of extra work, right? Now there's some tools that help you with it, right? Like Lombok has a at non-null annotation you can put on parameters that will generate the null guards for you. Sure, but that's still a runtime check, right? It's going to blow up at runtime or in your unit test, maybe if you're testing null case or something like that, right? But Kotlin can do you one better. So in Kotlin, we have compile time checks on nullability. Every type kind of has 2 flavors. You can think of it as like in the type definition of any kind of reference, there's an extra bit in that definition that says it's nullable or non-nullable. So to declare something as nullable, you put a question mark at the end. For non-nullable, you just put nothing. And it's by default non-nullable. Well, null was the billion-dollar mistake, right? So the default really should be not nullable. We don't want to deal with nullable things. So what this does is, if you declare something as nullable, you can assign null to it. So we see that here. We're assigning null to the value longest. What Kotlin also gives you is if something is nullable, it gives us better tools to deal with the nullability. So what we see here is we want to check, is the new string greater than the existing longest string? Well, as we go through, if we try to check the length on something nullable, Kotlin won't let us, right? If you typed longest dot length, it would be a compile error because longest, so a thing of type nullable string does not have a function called length on it. To get that length, you need to have a non-nullable string. That's the class that actually has that function on it. So, or empty is a function that Kotlin has on its string class, on the nullable string class specifically. It only exists on the nullable string class that returns the string if it's not null, but if it is null, it'll return an empty string. That's just one way to have a fallback. Another way to have a fallback is you see it at the bottom there. So we have longest, right? We're going to get the longest. We can do a question mark dot instead of dot. So what question mark dot says, if this is not null, then like let's basically smart cast it to a non-null version of that type. So that's, and then let us call length, but length will now return a nullable int, right? And we don't want a nullable int. Actually, I just noticed a typo in here. And the function definition of get longest int should be after the function, and it should be declared, in the Kotlin syntax. But int is not nullable here. It doesn't have a question mark after it. So we need a non-null int. So we can do what's called the Elvis operator. This is this question mark colon. And if you turn your head sideways, that looks kind of like Elvis. Okay. What that does is say, if the thing on the left is not null, then we'll return that. But if it is null, then we'll return the thing on the right. It's kind of like an optional dot or else in Java, but it's just built as an operator in Kotlin. It's just syntactic sugar. So here we can say, okay, our fallback is going to be 0. So we can take longest, we can get the length out of it, but if it's null, we're just going to fall back to 0. Okay, so that's how we deal with things that can be null. But things that can't be null, if we look at our test function, test takes a non-null string. If you try to pass in a parameter anywhere in your code that is of a nullable type, the type of that thing is the question mark on it, it's a compile error. So it'll only let you call that function in your code if you're passing in stuff that is already declared to be not nullable. This is probably the most important feature of Kotlin, the way it deals with null handling. Mostly because the way Java does it is rough, right? Everything being nullable by the default. This is one of the biggest things that improves in Java. If you have a logging aggregator at your work, like a Splunk or something like that, or a Kibana log stash thing, query for how many null pointer exceptions you have in your logs. And when I did it at my work, it was on the order of tens of millions per month, I think, when we were still a pure Java shop. And none of those would happen, basically. Practically none of them would happen if you're using Kotlin. Okay, moving on. Use overloading judiciously. So what that is saying is like, don't go overriding stuff willy-nilly, right? It's if you have two functions that have the same name, then it can be confusing because depending on which one you call, something different could happen, right? But there are valid use cases to overload, right? So for example, if you have a sandwich factory, we want to make a sandwich. But then you want to be able to customize your sandwich, right? Not everyone wants to eat the same sandwich. So let's allow you to pass in bread. And so you can either get a default sandwich that's going to have white bread, or you can have sandwich with whatever bread you want. Let's give you some more customizable options. Okay, so now let's have, we can customize our bread, our protein, and our cheese. We can customize our bread, our protein, our spread, and our cheese. We want all these different overloaded methods. It's just like different parameters. And really, there's one real implementation, right? The one that takes all the parameters is really like the real implementation. And then all the other ones are just like shortcuts, right? That just call the main one, but then with some default values filled in, right? It's kind of like this telescoping overloading. I see this pattern a lot in Java, right? Because it's just a nice experience to be able to pass a variable number of parameters and just get the defaults in some cases. In Kotlin, we get this for free. So if you have default parameters, you want default values on your parameters, you can just declare those right in the function itself. Have one copy of that function declared. And from there, you can call any combination of those functions. The only thing is that if they don't have a default value declared, if it's just no equal sign, it's just a comma, then you have to always have that parameter in there. Otherwise, if it has a default parameter, you can just omit it. It doesn't have to be there. And you can put them in any order if you put the name in there. If you don't have the named parameters in your invocation there, you have to put them in the correct order. And then this is the last one I'm going to go through here. Avoid unnecessary use of checked exceptions. All right. Well, this is easy. In Kotlin, there's no checked exceptions, so done. But I kid. It's true. But in Kotlin, there's only runtime exceptions. There are no checked exceptions, and there's a valid reason why checked exceptions exist, right? Because there are some errors that are recoverable, right? So if those happen, we want to force the developer calling your API to deal with and somehow recover from this exception, right? The Kotlin take on this is that, well, if it's a recoverable error, it's this is control flow now, and it should not be an exception. So we should deal with that another way. And I'm going to talk a little bit more about error handling in Kotlin in my next talk. So I don't want to get too in depth with it. Basically, there are no checked exceptions. Never have to worry about a checked exception with Kotlin. This is a little bit of a controversial take, but hopefully by the end of my next talk, I'll sell you on it. So my slides for this talk are right here on my GitHub. And so let's take just a few minutes. If you need to take a break for whatever reason, go ahead and do that, and I'll address questions in the chat real quick while we do that. So I guess go ahead and ask questions in the chat if you have more questions in the chat, and I'll address them. And then once you run out of questions, I'll move on to the next talk. So the first question was, you talked about top level functions just now. Is this how extension functions work in Kotlin? I've just heard about them, but don't know how they're created in Kotlin. Okay, so top level functions and extension functions are a little bit different. A top level function is a function that can be declared without reference to any kind of class at all. You don't have to call any kind of instance dot or class name dot. You just call the function by itself out of nowhere. And that's a top level function. An extension function is a function that you're adding to an existing class. So we have, say, a class called string, right? That's Java lang string. And you have a common use case of string where, like, for example, that one I showed where it's dot or empty, right? So if this string is null, then we want it. Well, this is not a good example because if it's null, you can't do an extension function. Let's take something else. How about converting a string to an int, right? So you can do like integer dot value of, right? And you can pass in a string, and that will convert the string to an integer, right? But that's not a very fluent way to do it, right? Instead, what if on every single string we just added a function that's that string dot to int, and under the hood that function calls string dot or integer dot value of passing the string, right? Something like that. That's what an extension function is, and that function actually exists in the Kotlin standard library. So when you call a string dot to int in Kotlin, which is something that doesn't exist in Java, it's still a Java lang string. This is not, Kotlin does not have its own special string class. Well, it kind of does, but it's just an alias. The under the hood implementation of string is actually the Java lang string that ships with the JVM, JDK standard library. It's the same string class. They just are able to decorate it with additional functionality using the Kotlin extension function functionality. So that's what that is. It's actually added to a class and therefore accessible via instances of that class, versus top level, where you can just invoke that function without any kind of class or instance reference. So I hope that clears it up. Okay. Right. Any other questions? I'm going to switch my screen here for my other slideshow. So that'll take me just a minute, and then we'll get started on the next one. Okay, I'm all set up here, and I think it's been about 4 minutes since I finished the last one, so let's go ahead and get started. Okay, so this presentation is all about Kotlin as a functional programming language. So let's get started here. We can skip ahead a little bit because I already talked about me, talked about Grubhub. Now, this part I like to do in front of a live audience, but I'm just going to say, like, I always like to see who has experience with object-oriented programming in Java, who has experience with any kind of functional programming, whatever language, and who has experience with Kotlin as a language. And for this talk, I'm going to assume that most of you have experience with object-oriented programming in Java and not those other two. And that's usually most of my audience when I'm giving this talk. Oh, I also ask who has experience doing both. I get people sometimes. So first of all, I want to cover what is functional programming. Oh, I have someone yes, yes, and yes. Okay, so that's good. Well, I think you'll still maybe hopefully learn something from this. Awesome. Okay, so yeah, so what is functional programming? A lot of people kind of think of functional programming as collection operations, right? Like filter, map, reduce. A lot of times when I talk about functional programming, people say, "Oh yeah, I know filter, map, reduce," and that is functional programming. That's not wrong, but that's not all it is. That's just one kind of expression of it. So for this talk, I want to get down to the basics of functional programming. I want to start from scratch. Assume you've never done functional programming at all, and talk about the basic building blocks of it. I don't want to jump ahead to some of the implementations, but I'm going to keep it practical, right? This is not going to be a math lesson. It's going to be how it relates to practical development. So first thing I want to say about functional programming is that it has a lot of the same principles as object-oriented programming. Okay, there's a lot of overlap. This is not an either or, you can do one or the other. There's a lot of overlap here. For example, encapsulation. Both paradigms highly value encapsulation. That's how you write reusable code, right? Don't repeat yourself. Well, I mean, the reusable code allows you to not repeat yourself, right? The Gang of Four design patterns. Now, this is a famous book written about design patterns a long, long time ago for object-oriented programming specifically. But the funny thing about it is, if you read through that book, a lot of the patterns are very applicable in functional programming as well. They are implemented a little differently, but the concepts, a lot of them are the same. And favoring composition over inheritance. Well, some people might say, well, object-oriented programming, the whole point of that is inheritance, right? Well, I think we've learned some things about object-oriented programming over the years. And one of the things we've learned is that inheritance can get very sticky, right? So in general, if you're just trying to reuse code, composition is a better pattern. Inheritance has its place, but it's shouldn't be your go-to, right? That's kind of, I think, the knowledge that's evolved over the years with object-oriented programming. And so for functional programming, it's the same thing. It goes hand in hand. That favoring composition over inheritance fits perfectly in functional programming. But of course, there's some differences, right? Because otherwise, words wouldn't mean things, right? So what is the difference from object-oriented programming? Well, for one, this is a very conceptual thing. Functional programming is focusing more on verbs, whereas object-oriented programming is focusing more on nouns. So think about it. When you define your classes, you're usually nouns, right? It's a thing that does something in your system. When you're doing functional programming, you're just defining functions more than classes. And those functions are usually a verb. It's doing something in your system. It's that action. So that's how the way you think about your system and your solution is in terms of the verbs of it rather than the nouns. On a more practical level, in functional programming, now limiting mutable state is a good idea in object-oriented programming as well, but in functional programming, it is paramount. And we'll talk a little bit about that in a little bit. So that's kind of like how functional programming differs, and it's the same as object-oriented programming, but those are just ideas, right? We can implement those ideas whether we're writing Java or Kotlin or Scala, Clojure, whatever you want, Rust, right? And that's absolutely true. You can follow these principles in any language. So what makes a language a functional language? Well, so I could be here all day talking about like functional purity, and I don't want to do that. Instead, let's talk about how Java and Kotlin are actually both multi-paradigm languages, right? We can do object-oriented programming or we can do functional programming in either one. We have tools at our disposal to follow those patterns and those principles. But in Kotlin, we have, so in Kotlin, we have just more tools to do it, basically, is what it comes down to. Some of the stuff is right out of the box, or if it's not, it's the language features make it easier for us to implement these things. And so when thinking about when you write some code, should it be functional code or should it be object-oriented code? We can do both. And actually in real life, most systems have both. Right? Nothing's ever purely functional or purely object-oriented, really, unless you're very, very dogmatic about it. It shouldn't be. There's some kind of natural point where you say, basically, you have your functional core. This is your functional area where all your pure functions live, and then you have your imperative shell, right? So the imperative shell is stuff like object-oriented, is where object-oriented programming shines. It has stuff like state, I/O, side effects, graphic user interface, those kinds of things fit into an imperative shell. This concept, functional core imperative shell, I have resources at the end, links to read more about this. But basically, that's what it says: is you have the shell around your system where you're dealing with state, you're dealing with I/O, you're dealing with interfaces, user interfaces. And for that, object-oriented programming is going to serve you better. But then in the core of your system, you're going to have all the business logic, right? And in there, that's where functional programming really shines, because you can have pure functions, no state, just pure business logic, and it's easier to test and everything like that. So the point is that if your language has more functional programming tools, it gives you more of those at your disposal, then where you draw that line between the functional core and the imperative shell can expand, right? You can write more things in a functional style, and that core becomes bigger and your shell becomes thinner. And that is what makes Kotlin more functional, all right? Because we can do more stuff in a functional style reasonably than we can in Java. Okay, so specifically those tools, I'm going to go through a few of them and talk specifically about what they do. So for one is immutable data, the ability to create immutable data. And I'll talk about the value of that and how we actually do it and how it's easier. Pure functions, what are pure functions? And I'll show why they're important. And then also, how do we do them in Kotlin and why is it easier? First class functions, which I talked about in the previous talk, right? And then we have functional types. And I'll talk about details about that later. I'm just going to go through these really quickly, and then we'll talk about more details. And then higher order functions. All right, now pretty much all of these things are possible to do in Java in one way or the other, but some of them are a little bit awkward to do in Java or just don't have the full power available in Java. Oh, one more thing. The type system, the Kotlin's type system is a little bit more advanced than Java's, and we'll talk a little bit about that. So let's start with immutable data. So first of all, there's a talk by Rich Hickey called The Value of Values. And if you haven't seen that talk, look it up on YouTube after this, not right now, and watch it. In that talk, he does a great job of explaining the power and the importance of immutable data, better than I ever could. But the TLDR version is that immutable data is good because it is thread safe. It avoids temporal coupling. Like, you don't have to worry about in what order are things mutating your state. You don't need to worry about defensive copies. And it helps prevent side effects, right? If you're not mutating any state, you don't have to worry about some function like randomly mutating something you didn't realize. And it's easier to cache because if an object can never change, it can easily just be cached. Okay, so that's a nutshell of like why immutable data is good. But like again, for more details, watch Value of Values by Rich Hickey. It's great. It's great talk. In Kotlin, the way you make an immutable data class is like this. So data class, which we already talked about in the previous talk. The main important thing here is the val part. So when we declare our properties on our data class, we put val there. That makes them immutable. So we can still use data class with var, and those are mutable data classes. But generally in Kotlin, that's discouraged. You usually want it to be val. That's how easy it is. That's all you have to do. And so if you declare a data class like this, you will not be able to set string data ever. It's passed in on the constructor, and then that's it. Can never set it. So it's very easy to do. All right, so next for pure functions. So first of all, I want to talk about what is a pure function. There's a couple of things that are properties of pure functions that have to be true for it to be considered pure. One is it's deterministic. That means the same inputs to that function, if you pass the same parameters, will always yield the same outputs or return value. Right, that'll never change. Given these parameters, the output will always be the same. No side effects. That means you do not access or mutate any kind of shared state in your function. The benefit of the pure functions is that they are much easier to test and know that you have 100% test coverage on than other functions. So let's take a look at what that looks like. Okay, so say we have a data class called chat message here, and we have a function that returns a new message. All right, so it's just basically like a factory method or something like that, right? We want to create a new message. We're going to give it a string, and it's going to fill in the details for us. So it already knows who the user is, right? We know what the current time is, right? We can just like fill that in with instant.now. Okay, this is not a pure function because if we pass the same message into new message, it will yield a different result based on the time, based on the system property, right? Now this is a kind of contrived example, but bear with me here. How we would make this deterministic is, well, we got to pass all those things in as parameters, right? Pass the message in, pass the user in, pass the timestamp in. Right, now we pass all those things to the constructor. But you might rightly object to this, saying, well, you're just kicking the can down the road, right? Somewhere you have to call instant.now, right? And somewhere you have to like get the logged in user, right? But the point of it is that we're pushing it out. Remember that imperative shell and that functional core. We're pushing things out, right? So in this core business logic thing, which is just constructing an object, that's what's contrived about it. That's trivial, right? But if this is doing some more logic, right? We're pushing all of the side effects part, we're reaching outside of the function into some kind of shared mutable state. We're pushing that part out of our core into our shell. So basically at our shell, like at the web API layer or something like that, that's where we can like get the logged in user from a token. That's where we can get the current server time. And then from that point on, we can just pass those pieces of information through our call chain to our core logic, right? But this makes this function very easy to test. It's fully deterministic. Now, in terms of side effects, we can also write to shared mutable state in a function, right? So if we have a function that is add new messages, right? So we have a list of messages and we have a new message we want to add to this list, right? And the function just takes the new message and adds it to the list, right? Well, you're modifying your input here. So that's considered a side effect. All right, that violates basically the principle of least surprise, because when you call a function and you pass in parameters, you don't expect it's going to actually mutate the things you passed in. So how you might so another way you can violate this is, say you have another function that's add a new message and you just pass the message in. Fine, let's make the list not a parameter. It's just another field on the class somewhere, and then we'll just add it to it. Well, now the function is reaching outside of itself to modify something that is not defined inside of itself, right? That's shared mutable state, and that's going to make things harder to test. Or, I mean, even if it's not hard to test, it might give you runtime problems, right? As other functions are mutating that same list, could get weird conditions, right? This is not a pure function. So how it would look as a pure function is, okay, fine. So we have our list of existing messages, no longer a mutable list, it's a list, which means it's immutable. And then a new message. And what we will do is we'll construct a new list that consists of all of the messages in the existing list plus the new message. And this operation is not expensive because basically what we're doing is we're like copying. The list is just like pointers, right, to the values, right? So we're just copying the list structure, right, and still pointing to all the same objects under the hood, right? And then we're just adding the new one, and it's a new list object, so we're not changing that existing list. All right, so these are like these are pure functions, right? And like I said before, you can create side effects in Java or Kotlin, right? You can create a util class in Java and make static methods, and you can still make all your pure functions in Java. Yeah, absolutely. And you don't need Kotlin for that. But Kotlin makes it easier with the first class functions feature, which I talked about earlier, right? So if in Java where we have like a utility class where we have a private constructor and we have our static functions there that give us those pure functions, where it gives a great place for those to live. That's great. Now, some people will suggest that static is bad and you should not use static. And to that, I say, yeah, usually that's true, right? In Java, static can it can be problematic, right? The thing is that with statics, there are one valid use case for them. And it is for it is for pure functions, utility classes. And even in effective Java, that's mentioned. So that is a valid use case of statics, right? That's like the one good time to use statics in Java, right? And that's what's really nice about Kotlin, that it says, okay, well, fine. Let's concede that there is this valid use case for statics, right? But most of the time statics are bad, right? If we don't want to use them. All right, well, instead, let's get rid of statics. There's actually no such thing as static in Kotlin. Let's just get rid of it and create something else that covers that just one use case, but can't be abused the way statics can. And that's what the top level function is in Kotlin. So we can declare these functions just like this, not inside of a class, right? And we don't have to worry about statics. There are no, like I said, there's no statics in Kotlin. So we can just declare our utility functions this way. I did put them here in a few different ways of syntax just to kind of show that Kotlin does have some flexibility in terms of how you declare things. So this the same function here declared 3 different ways. The first one looks pretty traditional, right? We have a function, has 2 parameters, has a return type of Boolean, and then we do an open curly brace and we return the result of our expression here that we want to do. The next one is a little bit of a shortcut. If your function is a single statement, then we can do a shortcut and just basically, instead of the curly braces, we can just say this function is equal to this expression. Similar to how in Java, when you have a lambda, that's only a single statement, like you don't need the curly braces and the semicolon and the return. You can just like get rid of all that and do the expression. It's the same concept here, but this is when declaring functions. And then finally, here's yet another way we can declare this function. We can declare it as a val, right? So this is no longer like function, right? It's not fun, right? It's val. It's like we're declaring a property, right? But its type, if you look at the type of the property, it's a function signature. Okay, so here we have a function signature of a function that takes 2 ints and arrow returns a Boolean. So now we have a property called big decimal equals, but the type of the property is a function with this signature. And we declare it equal to this expression. And it can be invoked the same way as any of those other function declarations above. So in our code, we can say big decimal equals open curly brace the same way we can for all these other ones. And I wanted to show this syntax here because it brings up the next important thing that allows you to do functional programming in Kotlin, which is functional types. So that's what this is, right? This is a type, the type of the thing, the type of the property or whatever you want to call it, variable, is a function. So in Java, right, we have at functional interface. This was introduced, I think, in Java 8. And it basically allows us to say if we have a class, well, it's called a SAM, right? A single abstract method class that just has one abstract method in it. Then we can decorate it with an annotation that says at functional interface. And if we do that, then any function that takes something of that type as a parameter, we can express as a lambda. This is how we got, this is the first implementation of like lambdas in Java. And this was in Java 8. In Kotlin, we can use these, right? Like if we have parameters and there are these functional interfaces like function and predicate and those kinds of things, we can automatically match them in Kotlin. So we can still do the thing we would do in Java where we can pass a lambda in. But see, the thing with Java is that like we get some of these functional parameters or functional interfaces out of the box, right? There's like function, by function, consumer, predicate, by consumer, like all these different ones we get out of the box. And then if you want to declare your own custom ones, you can do that as well. But in Kotlin, you can just declare functional parameters without that. And I'm going to show you exactly what I mean. Okay, so say we have a function here that's called contains, right? And we have a collection and we have a predicate. Now, predicate is something that takes an object of type T and returns a Boolean. So it's a test, right? Test if this condition is true. So in our contains function here, we say, okay, for each item in this collection, let's test our predicate. So take the predicate, call test on it, pass in the item in the collection. And if that is true, then we will return true from contains. Otherwise, we'll just keep looping. If we never find anything, then we'll return false. So what we're doing is, does this collection contain something that matches this predicate? So basically, does the collection contain an item that satisfies this test? Right? So this is what this is doing. This is Java code right here. Okay. If we declare this, then we can call the function like this. Contains, we have our collection, and then we have our predicate, and that's a lambda, right? So we have something that's coming in, the thing we want to test, and the thing we want to return out of our predicate is test if the length is greater than 1, say, for example. So if we want to test, hey, does this list have anything where the length is greater than 1? Then we can do that, and this will return true, right? But we could pass any predicate in there that we want, right? But all of this only works because of this predicate functional interface, right? Now, this one happens to come out of the box in Java. But if you have a different Lambda signature you want, you have to declare that functional interface. That's an additional class you have to define yourself. In Kotlin, it looks a little different. So like I said, we can do interop with Java. We can call predicates as lambdas, fine. But we don't have to if we're writing pure Kotlin. If we're writing pure Kotlin, the main difference I want to show you here is this predicate parameter. So now instead of a predicate of type T, we just say the interface signature, the signature of the interface, right? So we don't have to reference specifically this is a predicate. We just say, hey, listen, anything that is a function that takes a T and returns a Boolean can come in here on this parameter. So the way that we invoke it is the same, right? Contains, pass in our collection. Now remember that thing from all the way back in the beginning of my first talk where I talked about lifting lambdas out of the parentheses. That's what I'm doing here. So, but all that is just the second parameter, right? The second parameter is a lambda, and there's the logic. It is, you get it as a reference to the input of the object. If a lambda takes a single parameter, you can just say it. You don't have to give it a name. That's similar to Groovy. Or you can give them names. After the curly brace, you can do a name and then an arrow, right? So for this, there's no functional interface defined. Because we just declared the signature on the type, that parameter has that type of that signature, and any lambda that satisfies that signature can be passed in. So what this does is it makes it very easy for us to declare what is called a higher order function. So a higher order function is a function that takes another function as an input, what we just showed there, right? It's a function, but one of the parameters is another function, right? Or it's a function that returns a function as the output. You have a function that returns something, and the type of the thing it returns is that function signature. Or it can do both, right? One of the great uses of higher order functions in Kotlin is basically a replacement for dependency injection, right? So instead of passing in an object that says, okay, well, my function here is going to call methods on this object, so I need to pass that in, right? Instead of doing that, instead, you can say, well, my function just needs reference to a function that takes a string and returns an int or something like that, right? I don't care where that function lives. Just give me a reference to a function that does that. And when you pass it in, you can say you already have the object, right, that has that function. You can just pass the method reference through, like object reference : the function, right? But it could be any lambda that satisfies that, right? So you don't actually like have to do the object style dependency injection, right? So that's kind of like the equivalent in functional programming. The other thing that it lets us do is abstraction over control flow. So I'm gonna show some examples here. So the replacing dependency injection thing. So like dependency injection is a very common pattern in object-oriented Java, right? And it's like the whole way you structure your code a lot of times, right? You think about it, that's what object-oriented programming does. It gives you programming structure, right? You have these classes and they have to call other classes, right? So you kind of have this like structure built, it's a graph, right? Where like these things depend on these things, and that's kind of what gives your code some structure. You don't just have things calling other things willy-nilly all over the place, right? So if you're doing functional programming, you're not building these like classes, right? Like in functional programming, your classes are usually your data classes, right? But your business logic is in functions, right? These top level functions, not necessarily classes. So how do you not just have a big bucket of functions and like how do you navigate that, right? There's no structure there. This helps give that structure, right? Because you can define, well, this function actually under the hood is going to call this other function to delegate some of the work, right? Or the implementation details, right? So instead of just directly invoking that other function, because that can make it hard to test in isolation, right? You want to be able to mock out that other thing, right? But you can't mock a function, like you can only mock a class, right? Instead, we lift that up to a parameter, right? So in this case, we have new message, right? And timestamp is a function that returns an instant, right? And our default implementation is instant.now, right? So in our production code, we can call new message with message and user, something like that, right? And just omit the timestamp and we're going to get instant.now. Now, that's what we want. That's the default. But in a test, we can provide a lambda in there, right? And just say, we're just going to like hard code this to instant.epoch, right? This isolates our other logic from that like side effect or whatever else it is, like another function that does something else in your system, gets some data from the database, whatever it is, right? We can replace it with a different lambda, right? It's kind of like a mock, right? But it's not a mock, it's just a lambda. So this makes unit testing code in isolation and functional programming easier. This is kind of like what I would pitch, like if you're saying, well, I can't do just functions because it's going to be too hard to test. You have a function calling a function, 20 levels deep. How do you test that, right? This is how. So this is like a thing that you can't really do in Java because Java doesn't have the default parameter, right? So if you were to do this in Java, then every method call would have to specify like what instant, right? Like that example at the beginning, like we're passing in the instant all the way through, right? This is what allows us to get around that. Actually, we can just say, yeah, sure, you can pass in the instant or a lambda, right, that returns an instant, but we'll declare a default value that's just instant.now because we know that that's 99% of the time what we want or something like that. That you can't do in Java. There's no default parameters there. So you have to like overload it and you say, this one's for testing and this one's for real. And it's not very elegant. The other thing it's useful for is higher order, abstraction over control flow, right? So here's an example of implementing or else. right? So think about optional or else in Java, right? How do we do that in Kotlin? So if we have a something of class T, right? This is a generic function, right, of type T. We have something of type T, but it's a nullable type T. Then let's declare a function on it. So this is like an extension function we're adding to anything, any class. If we're doing it type T, it's anything, right? So anything, any class, if it's nullable, add a function to it, dot or else. And then have a lambda that's just a function that returns a T, right? So basically the implementation of this thing is going to say, if this is null, then call our fallback to get the value. Otherwise, return this. Now, this function or else returns a T, not a nullable T, because fallback returns a T. So we're able to say, if this thing is null, return fallback, which will definitely not be null because we declared it's a function that can only return a non-null T. Otherwise, well, return this, and this, even though it's a nullable type, we've already done the null check. Kotlin can smart cast that to a non-null T and allow us to return it as a return value for our function. Sorry, I know there's a lot there. But the important thing here is that this is a function that is basically the null guard with fallback, right? It's basically control flow, right? Like it's typically in stock Java, this is a, if this thing is null, then this, else like this other thing, right? So it's the null guard, it's the control flow that we're going to abstract over. Now, the interesting thing is, so yeah, so if you have a nullable of types, say a string, a nullable string question mark, then you can call on that dot or else, and it will never be a null pointer exception. Even if the thing is actually null, you assign null to it, you can still call dot or else because Kotlin is smart enough to like execute it on a thing of that nullable type. Okay, so you can see that here's how we would use it. Like we can have a nullable string and we can call dot or else and provide a lambda that returns like a fallback. I mean, it doesn't have to be a hard coded fallback. It could be a function that calls something else or whatever else, right? But now it's a higher order function. The function is called or else. It takes a lambda and the control flow, you see it in the implementation of or else, right? That if this thing is null, do this, otherwise do that. That control flow is there in the implementation. But we don't have to copy that if else block everywhere in our code, right? In our code, we can just call dot or else, and it's a higher order function that performs that control flow under the hood. But we can pass any logic in as the functional parameter, right? That's what makes it a higher order function. So doing this allows you to encapsulate more abstract concepts. That's the important thing here. You're not just abstracting away like simple kind of like checking some values and doing kind of things like that. You're starting to abstract over the shape of your code itself, your control flow, your common design patterns. All of those kinds of things are now abstracted away. And that's why when you talk to a lot of like functional programmers, they're going to use all these like crazy words you've probably never heard of, right? Because after you do that enough times, you start to develop like words for these things. Once you recognize these patterns, like, oh, I end up writing this higher order function that does this, and this. And like that becomes long-winded. So then you start to coin terms, names for these things. And that's where you get a lot of the weird terminology and jargon in functional programming. And that's why I'm trying to avoid those entirely in this talk for the most part. Because it can be very intimidating and confusing to people new to it, but that's what that is. And that kind of emerges as you practice, right? So like as I go through the rest of this talk, a lot of it, it's going to be stuff. Now I'm starting to get into some stuff where until you actually get your hands on this stuff and start doing it in your work, you might not fully get it. And that's okay. It took me years to understand this stuff, right? Just practicing it and taking incremental steps, starting at the very basics and then just seeing, aha, okay, I see. Next thing I can do is this. Next thing I can do is this. And then you start to understand why. But some of the common examples of higher order functions that you'll see right away are the Kotlin scope functions. So these are functions that exist on any object that apply. They're like simple, like kind of transform functions. Collection operations. So this is we're finally full circle back to what I said what is functional programming. And one of the expressions is those like filter, map, reduce kind of collection operations Those are higher order functions, right? Think about them. When you call map, you pass in a lambda, right? And then it's going to apply that lambda to every item in the collection and return the new collection, right? The filter does what it says, right? It checks a predicate. That's a lambda you're passing in, right? And will drops the thing from the collection if it matches that predicate or doesn't match that predicate. All right. So those are the common things. Like I'm exempting some of the more complicated examples for now. Finally, I want to talk about the type system, right? And I've already touched on this a little bit. In Kotlin, we have nullability built into our type system. That's huge. That's highly important. But some of the other things it has, sealed classes. Now, Java got this in Java 17, right? So if you're lucky enough to be on Java 17, hopefully you are, then you can use this in Java as well. But it's something that's been in Kotlin for a very long time, and is very important when doing functional programming. And finally, I want to talk about pattern matching. Again, finally getting added to Java, but I really do think that Kotlin having these things really helped push Java to include them. So for nullability, we've already talked about this. We could declare things as nullable, and then you can assign them to null, as null, or not nullable. You can assign that. You can't. It will be a compile error if you try to assign something that can be null. Okay, so sealed classes. So what a sealed class is, and this is true for Java and Kotlin, what a sealed class is that it allows you to have a restricted type hierarchy. What that means is if we have a class of type thing, and then we can extend that class, thing one extends thing two extends thing, right? But nothing else can ever extend these things. So now, after this like compilation unit, this file is compiled, we have no others. It's basically effectively final, right? Nothing else can extend it. And that's very important because it allows us to say like, basically allows us to check some things at compile time that otherwise we wouldn't be able to do. And the prime example of this is pattern matching. So if we have something like this, a when is like a switch, right? In Kotlin, it's called when. In Java, newer versions of Java have the newer switch expression. So it's similar to a switch. But if we have something of type thing, which is that superclass, right? And we check if its instance is just as an instance of check. If it is an instance of thing one, then now it's smart casted. So now we can access a property that's on thing one that doesn't exist on thing two, because Kotlin now knows that this is actually, the compiler now knows this is actually a thing of type thing one. So I'll grant access to that API for you. Then we drop into our next case. If it is thing two, then let's do the thing that we can only do on thing two, right? But if I forgot is thing two in this block, compile error, because it's actually able to check that have we covered all of our cases. The compiler knows every possible type of thing that can exist. If there can be a thing one or a thing two. Those are the only subclasses. So if we don't cover all of them in our when expression, it'll be a compile error. Now they can do a default. So if you could do an else at the end and say else, if it's anything else, then do this. And then fine, it can't know like if you're exhaustive. Well, you are exhaustive by definition, right? Because it could always fall into the else. But without an else there, you're guaranteed that you'll always cover all your cases here. That's really, really nice. You never have to worry about like, oh, I added a thing three in my class and I forgot to go over to this like expression over here and make sure to add like behavior for that. Like what if it's thing three? Like you don't have to worry about that. If you add thing three, compile error. Oh, when it will say when this expression is not exhaustive, and you need to go in there and actually say, okay, now what if it's thing three? And so what that brings us to, this is an important building block for something called monads. And now I know this is starting to get scary, all right, but bear with me. I'm going to try to break the monadic curse here. And the monadic curse says, once you understand what a monad is, you lose the ability to explain it to somebody else. I have a trick that I've trying to use here to break the monadic curse, where I just never let myself fully understand what it is. And so I'm not an expert on what is a monad, but I think I know just enough to try to explain it a little bit and why it's important. All right. So here's my take on what's a monad. A monad is just a higher order function expressed as an object, right? So instead of a function that you call, it's now an object that basically contains that same concept as that higher order function. That's number one most important thing. And the other number two most important thing about it is that it's composable, which means you can like have a monad and then you can like apply, you can call like a function on it because it's an object now, right? It's reified as an object. You can call a function on it and to transform it in some way or operate on it in some way, but you'll always get back that same monad as the response, the same type back. As so that's what makes it composable, right? It's really easy to chain together calls. All right, so a prime example of what is a monad is optional in Java. Well, we should all be pretty familiar with this by now, right? An optional you can create of anything that's nullable. You can check if it's present. You can do or to get a fallback. You can map it. You can filter it. Right? Kotlin has the same concept, but it's just with nullable types. That's just syntactic sugar around optional. Right? If it's nullable, then you can check if it's null. You can have a fallback with the Elvis operator, right? You can map it by just calling functions on it, or with the let operator, or not let operator, the let function. All right, but this is a monad because if I were to call opt dot something, right, question mark dot, I can just chain that because that returns another nullable thing. And I can do it again and it returns another nullable thing. I can chain that. Likewise with optional, right? If I call map or filter on optional, I get back another optional, right? And if or flat map even, right? So that's chainable. That's what makes it composable, right? We can also do the flat map, right? So if we have two different optionals and we want to map it, and then inside the map we return another optional, then and we want to not have an optional of an optional, right? It flattens it. But this is what makes our code composable, right? Collection, like this Java streams are the same way, right? You chain your operations on the stream. A stream is another monad. But like, remember the other requirement is that it's abstracting over a higher order function, right? So an optional monad abstracts over the null check. That's the higher order function. Streams or collections, they abstract away the for each construct, right? That is the basically the original sorry, I'm blinking. The original code structure, right? That you can then write a for each method, right? Like on your collection that is a higher order method, higher order function that abstracts over the for each construct in your code, right? Control flow. And then on top of that, we can have an actual collection operation that the collection classes or stream, that is the actual monad that encapsulates the whole idea of having an iteration over a collection of items as an object and is composable. All right, so I'm spending a lot of time on that. But I want to talk about probably the most important monad outside of like optional is either. So either monad, remember we talked about sealed classes. This is where they come into play here. And either monad says, I am a container for something of type A or type B, right? So the class itself either is of type A comma B because we need a reference to both of those types, but the actual implementations are left or right. I'm either left or a right, an A or a B. So left will have a value of type A, right will have a value of type B. All right, so when we create it, a value of say E here, and it's an either of type string or int, right? So this variable E will contain either a string or an int. So we can say when E, like a when, a switch expression, right, is left, then we know the value is of type string because it's casted to that left class type, and we can access it as a string. If it's of class right, then we know that is an int, the value is an int, and we can treat it like an int. This is all compile time checks. That's what differentiates it from Java. In Java, you can do stuff like this, but a lot of the checks are still going to be runtime checks. In Kotlin, we can make it compile time through the use of sealed classes and the smart casting feature. Okay, so that is an either monad. And then kind of the next monad is sometimes called a trimonad or sometimes called a result monad. And this is really just a more specific type of either monad, right? Except for, so when in the either monad, we had type A and type B, right? With a try or a result, we have type A, and the other type is always exception or error or something like that, right? It's a hard-coded type. It's not genericized. So we have try of type A. It's either going to be a success or a failure. If it's a success, it'll have a value of type A. If it's a failure, it'll have a value of type exception. It's not a wild card. It's not generic. It will always be exception. So we can build a higher order function called do try, where we give it some work that returns an A. And then inside there, this is where we're abstracting over this control flow of the try catch block. So we do a try catch block, and we'll do our work, right? And we'll just wrap it in success function, right? Like create a new success object, pass in work. The result of work is something that returns an A, right? If anything happens that throws a runtime exception, it's going to obviously not return the success object, right? It's going to bubble up an exception. So we catch that. And in our catch, we just wrap it in a failure now, because now we know we have an exception to deal with. We just wrap it in the failure implementation of the try class and return that. So in the end, do try returns a try. We're not sure if it's a success or a failure yet. It's just a try. So if we have a result, we say equals do try, pass in some lambda, right? That's the work that we're passing in. So it's a lambda that returns a string in this case. It could be a call to a database, some kind of thing that could fail, right? Maybe it's calling another API or calling a database, something like that, right? So then we can do our win expression on result and say, if it is a failure, then like do our error handling, whatever we want to do for an exception. Or if it is success, then like we have our value and do whatever we do with our value, right? But remember, the important thing about a monad, it's not just that it's abstracting over control flow here, but also that it's composable. And I'm going to show you that. So hold that thought for 1 second. I just want to really quickly mention some other common types that are monads. Completable features in Java, that's a monad. There's a library called Arrow for Kotlin, and it has a object called IO. That is a monad that abstracts over doing the IO. And collections, I already mentioned how collections are monads. All right. So, but going back to that try example, right? Composing these kinds of try monads or result monads is a very powerful concept. And I know we might be getting a little bit abstract here, but I really want to give you a little bit more about this thing called railway-oriented programming, so that you can go and look it up later once you have wrapped your head around these like result monads a little bit. But the result monad is so powerful that it spawned like a whole new paradigm of programming, basically called railway-oriented programming. Now, that term was coined by someone named Scott, who has a blog called F# for Fun and Profit. And yes, that is F#, the language for the .NET framework. So this blog was written a long time ago, but it kind of outlines this pattern of chaining together result monads to be a new way of handling errors. This is why Kotlin doesn't have checked exceptions, basically, because there's this new way of handling errors. It's a whole new way to do it. I want to talk through it real quick. So remember that try monad we just talked about. We can add a function to it called and then to make some composition possible here, right? So this is basically like a map function. It says, so we have a try of type A. We're going to add a function to it that is of type A and B, right? So the function parameter is a function that takes an A and returns a B. So if we have a try of type A, then we can call dot and then and pass in a function that takes an A and returns a B. And so the implementation of this is, well, okay, so let's do a when switch on this. If we're already a success, then let's go ahead and call do try again, this time calling the next unit of work. That's going to take the result of our first unit of work, right? Our first result, take the value out. We know it's an A because this is a try success, right? Pass that into the next unit of work, and we're chaining together our work, right? But we're wrapping that in a do try so that this function also returns a try. Then check if it's a failure. If it's a failure, then let's just pass it through, right? The only thing we have to do is unwrap it, because now instead of a try of type A, we want a try of type B, right? Is what we're returning. So we just unwrap the exception out of the original try and pass it into the new try that's of type B. So the way this looks in practice is we have a result. Let's do try lambda that returns a string or whatever. And then we can just start chaining and then find its length and then add 2 to it. And then check if it's less than 0, right? Now, in reality, these would be like things that could actually fail, right? Like calls to the database or other systems, things like that, right? At any point in time, any of these things might throw a runtime exception, right? And if they do, then all of a sudden they are now a failure, right? And every time you hit the end, then it'll hit that failure case and it'll just unwrap the exception and pass it into the next try. At the end of the chain, we can check it, the result. If it's a failure, do our error handling. If it's success, we get the final value of that final unit of work. So what this does is it really lets you kind of like chain together lots of successive calls that could fail, right? In a way that's really easy to read, right? You have your top level. This is kind of like your imperative shell almost, where you say, okay, here's what I want to do. We hit this endpoint and it's going to do a lot of things. All right. First, we need to get like some information out of the database. Then we need to send this other system. Then we need to fetch this other thing from the internet and do this other thing, process this file, then do this other thing, right? Like a lot of stuff that could fail, right? But you see it all right here in very plain terms. You say we're doing this and then we're doing that and then we're going to do that and then we're going to do that. And we're passing the result of one function into the input of the next function, but all the way down, basically, if it ever hits a failure, it's not going to do the other units of work, right? It's going to take that failure and just start passing it through. And that's where the railway comes from, right? We have the, we'll go back for a second. Oops, what happened there? There we go, sorry. We have that green track on top, that's the success case, and we have the red track on bottom, that's the failure case. So at any point in time an exception happens, we're following the red track. We just ride that all the way through and we stop doing any of the other work. So that's basically a map function. I called it and then, but it's really, that's what a map is, right? And then we can do a flat map too, right? In this case, the only difference is that our unit of work itself is returning a try, right? So if you already have a function that's like nice, that it's doing your try, it's doing a try catch and returning a try, it's being a good citizen with this railway oriented programming, and you want to compose it, right? Now, well, that's already a try object, so you don't need to wrap your call to next in do try. Instead, you just return the result of next. Other than that, it's exactly the same. So that minor little difference allows us to then, we can do map or flat map, depending on if our lambda is going to return a thing of type B or a thing of type try of B. So that's how we make our monads composable. Now, I don't recommend you write all this code yourself, right? Like I mentioned before, there's a library called Arrow for Kotlin that has like these monads just out of the box. They've implemented them for you. I highly recommend doing that. In Java, if you want to do the stuff in Java, there's a library called Vavr. Kind of looks like if you turn Java upside down, Vavr. And they have a lot of these monads built in for Java. At least a lot of the checks are like runtime instead of compile time, but a lot of the same concepts are there. So don't implement it yourself, right? But it's important to implement, understand why they exist. Like, what is a result monad? Like, it's hard to just like understand that unless you've written it yourself. At least that's the way I learn, right? If I've done this kind of like lots of try catches, and it's like, oh, I want this thing to return one thing if it's an error, or this other thing if it's not an error, and like trying to figure out how to do that. When I did discover these things, these result monads, I was like, oh, this is a really nice solution to that problem that I keep reinventing in my own code in very bad ways, right? Some people smarter than me came up with this, and it's a really nice pattern. But it's helpful if you hit your head against that wall a couple times first to understand really what you're getting out of this. So yeah, I don't want to get too deep in the weeds. I know at the end here, I did, but the important thing about it is I wanted to give you just a little bit of like the vocabulary around it so that when you see these terms elsewhere, you'll kind of have a reference point, right? You're not going to fully understand everything I just told you if you've never dealt with functional programming before. But hopefully I covered a lot of the basics so that when you see some of the other tutorials out there, introductions to functional programming, you'll understand a little bit more about the context behind how this stuff is built. Because I feel like a lot of stuff kind of like when you go up and read about what is functional programming, like they just start talking to you about monads like right away. And so I was frustrated with that when I was learning it. So I wanted to help people with some of the stuff you need to learn before you learn about what a monad is. But here's some more resources. I have an article on my website there about using what some people call like ad hoc polymorphism to test functional Kotlin. So that's more about like how those higher order functions replaces dependency injection. Doing static web development with Kotlin DSLs. I love static web development, so I have an article about doing that with Kotlin. And then some stuff other people wrote. So there's the original railway oriented programming blog, a great article about why objects should be immutable, the value of values talked by Rich Hickey, a great article about the functional core imperative shell concept if you want to know more about that. And then Simon Wirtz has a great breakdown of the Kotlin scope functions. That's like let, apply. I kind of glossed over those because there's so many great tutorials on those online. Like you can just go look those up and that's great. But if you want to know more about like let and apply and run those functions in Kotlin, there's a great guide to those there on that link. If you want to get these links, you can get my slides here at this URL on my GitHub. And that's it. So I want to thank again Bruce and everyone at St. Louis Jug for having me here, and I can take questions and hang out. And also, I'm in, like I said, I'm in town. If anyone is like in the downtown area, I'm in like the Forest Park area actually, but I could go downtown. If anyone's like around, wants to hang out and just meet and grab a drink or something, I'm totally up for meeting up. So just let's we can chat, put in the chat or whatever. Yeah, so yeah, go ahead and put any questions in the chat and I'll hang out here until no one else wants to talk.
All right, so does anybody have any questions here for John? You can put those in chat, like you said. I'm not seeing any here.
Also, if anyone's in Chicago, come visit Chicago Kotlin user group or Chicago Java user group. We're two groups that meet regularly in Chicago. We're on meetup.com and we love seeing new faces there. So if you're ever in town, and it lines up with our events, come say hi.
All right, great. Well, thank you, John. Usually at this point, if we were meeting in person, we'd have a big round of applause, but I suppose we can do that in chat or whatever.
Oh yeah, that's like someone did one. Cool.
All right. Yeah, there goes
I,
one.
I hope this was helpful. And yeah, I mean, Kotlin's only getting more and more powerful, more and more popular. So, and obviously, I mean, I've been using Kotlin since about 2016, 2017. I like it. That's why I talk about it. So I think more people should look into it. So hopefully this was helpful. But also feel free to reach out. You can find me on like social media. Like I said, I actually think my other slides did have my Twitter on there still. You can DM me on Twitter. I'll get a notification or something, but or Mastodon.
All right. Well, thank you very much. I'll give you a clap.
Thank you. Thank you so much for having me. This has been fun, and I'm glad to be down here. It was a great excuse to come to St. Louis. I haven't been in many years, and so yeah.
Well, great. Thank you. So what I'm going to do is I'll end the recording, and I hope everybody can make it here next month. So we'll see you next month. So hopefully I can find that stop button on the recording.